See this problem. If the potential V of x is infinity, what is the value of psi of x? The potential value is given to you. They are asking the value of the wave function. To find the value of psi of x, write down the Schrödinger time independent wave equation in the one-dimensional form. See this minus h cross square by 2m d square psi of x divided by dx square plus v of x into psi of x equal to e into psi of x. In our problem, they have given the value of v of x equal to infinity. Therefore, v of x into psi of x equal to infinity. Infinity to anything? Infinity. Now the left hand side becomes infinity, whereas the right hand side is e into psi of x. See, this equation is valid only if the value of psi of x is 0. Since the value of e is finite, if you put psi of x is 0, left hand side is 0, then the right hand side is also 0. Now we can write the above equation is valid only if the value of psi of x is 0, since the value of E is finite. Energy value is finite, therefore psi of x should be 0. If the potential energy V of x is infinity, automatically the wave function value should be 0. Now we should realize the meaning of psi of x equal to 0. If psi of x equal to 0, the position probability p of x comma t is also 0. If v of x equal to infinity, then the value of psi of x equal to 0. If psi of x is 0, p of x comma t, this is our position probability, which is equal to psi star of x into psi of x, which is absolute square of psi of x equal to 0. Now we have to write the conclusion for this. If the potential V of x is infinity in a particular region, then the probability of finding the particle in that region is 0. This means the particle cannot exist in a region of infinity potential. This is the conclusion we have arrived. See here, if V of x is infinity, then psi of x is 0. If psi of x is 0, the position probability is also 0. Then directly we may say, if the potential V of x is infinity in a particular region, then the probability of finding the particle in that region is 0. This means the particle cannot exist in a region of infinity potential. The availability of particle in an infinity potential region is 0. To confirm this, consider the particle in a box problem. The one-dimensional box of infinity height and width L, x equal to 0, here x equal to L, then the particle of mass m is present inside the box. Now we have to write the condition for potential. V of x equal to 0 at x greater than 0 less than L. See this condition? The potential is 0. Suppose the particle is present inside the box. X is greater than 0 but less than L. This means that the particle is existing inside the box. At that stage, the potential is 0 and V of x equal to infinity at x less than or equal to 0 and x greater than or equal to L. Take the first condition, x equal to 0 and x equal to L. At the boundaries, the wave function vanishes. The value of psi of x is 0. If the value of psi of x is 0, the position probability is also 0. And take the second condition, x less than 0 and x greater than L. This condition implies the particle is present outside the box in the left hand side. This condition describes the availability of the particle outside the box because x greater than L on the right hand side. Here the potential V of x is infinity. If the potential V of x is infinity, the position probability is 0. So outside the box, we cannot expect the availability of the particle. Therefore, we may conclude that if the potential V of x is infinity, the value of psi of x is 0. If psi of x is 0, the position probability is also 0. Thank you.